All right, we're coming back at it again with a systems problem from Complete Problem Set 2, question 1. A 1,200 kilogram truck is pulling a 900 kilogram trailer to the right by generating 340 newtons of force. The truck is experiencing 580 newtons of drag, and the trailer experiences 320 newtons of drag. We can neglect friction, and we can neglect the mass of the cable. Oh goodness. So, we have a complicated system here. It's made up of two individual pieces which we have to analyze, but the sum of their masses together needs to be considered when we look at the acceleration of this system. Right? So we see there are two things colored green here. That's your first indicator that we need to actually analyze each part of this system as two separate components. The first thing I'm going to do is identify a motion coordinate system. Since my truck is driving to the right, I'm going to define the right way to be the positive x direction. Okay. I'm then going to begin by doing a free body analysis of the trailer. So I'm going to draw my dot. The trailer has the force of gravity, its weight acting down, and an equal opposite force called the normal force acting up. We see that there is a cable attached to this trailer. So that cable is going to be pulling on the trailer with some force of tension. And then we're told in the problem that there is a drag force, and that's given to us in this problem. So I'm just going to do FD for drag. I'm then going to move over and look at my car. I'm going to draw the car's center of mass as a point. I know that the car is going to have, its own weight due to the force of gravity. I know that the car will have a normal force because it's in contact with the ground. I know the engine of the car is, whoa, what happened to that line? The engine of the car is generating, it is not letting me make a nice line. The engine of the car is generating an applied force, and the cable is also attached to this car, which is going to create my force of tension. And I do see that there's an additional force, which I can't really draw in due to a drag force there. I would have that extending from the tension force, but just you get the idea. Goodness, that is a lot of forces acting on our system. So how many forces are acting on the trailer? We see it's 1, 2, 3, 1, 2, 3, 4. 4. How many forces are acting on our truck? Normal force, applied force, gravitational force, drag force, tensional force. 5 forces. That is the most that I think we've dealt with yet. So, second step of these problems, we are going to set the sum the forces rather, and set them equal to mass times acceleration. So for the cart, we're going to look at the, oh, that is a highlighter. We do not want a highlighter. I liked that mint green though. Can I find that mint green? Yeah, that's a nice color. We're going to go, the sum of the forces on the cart are equal to, well, I'm not going to worry about the up and down forces. We can see from our free body diagram that those forces are balanced, right? They will not cause an acceleration in the up or down direction. I'm only going to be worried about the horizontal forces. So we defined the right to be positive. So I'm going to start with the positive value. That's my force of tension. And I'm going to subtract from that my drag force, FD. And it looks like I've done those two. So I'm all set. I'm going to set the whole thing equal to mass times acceleration. I'll then come in and fill in any numbers that I have. I do not know the force of tension in this problem. However, I am told the drag force acting on the trailer is 320 newtons. So we'll write in the 320 newtons is equal to the mass of the trailer, which in our problem is told is 900 times the acceleration. Okay? Usually when I'm at this point, I like to kind of isolate one variable that I can come back to later. I can either isolate A or T. I think, because I've done these problems enough, that the tensional force is the one I'm going to want to consider. So I'm going to leave FT on this side of the equation, move the 320 newtons over, and I'll get an expression that says 900 newtons plus 320. Oh, not newtons. Let's hope we keep that right. 900 times the acceleration plus 320 newtons is equal to the force of tension. This becomes an equation I can reference later. So we're going to box it up. Make a pretty horrible box there. And then, yeah, that's really, that's quite pathetic. So how about I just kind of, woo, there we go. We want to just keep that in mind for later. I'm going to take this whole thing and I'm just going to shuffle it off to the side and maybe make it a little smaller and tuck it down over there. Okay, cool. Let's go and analyze the other free body. Let's do that in a new color. How about this beautiful blue? We're going to look at the sum of the forces on the actual truck is equal to, well, again, I'm going to ignore the normal force and the gravitational force. Instead, I'm going to deal with my applied force in the positive direction and subtracting from that the force of tension through the cable and the drag force that will be slowing it down, Fd. And all of that is equal to mass times acceleration. Okay, we'll then go through and plug in some numbers. We are told that the truck is 1,200 kilograms. It has 340 newtons of force applied and 580 newtons of drag. So let's see if I can keep that in my memory. We are told that it's, nope, I already forgot. It was 340 applied. So we have 340 newtons of applied force minus the force of tension, which we don't know, minus short-term memory says 320 newtons. No, that's for the trailer. It's 580 newtons for drag on the truck. 580 newtons equals the mass of the truck, which we're told is 1,200 kilograms times acceleration. Kind of running up on a curve here, so I'm going to try and readjust myself. Okay, I think right now what I'd like to do is just kind of simplify like terms. 340 minus a 580. 340 minus a 580. I get a negative 240 newtons. So I'm just going to write that in there. So the thing is negative 240 newtons minus Ft equals 1,200 times A. So right now we're in a situation where we have one unknown and two unknowns. Right? We can't solve this equation with two unknowns. So what we have to do is go back to our original equation, which we solved for Ft, take that value, take that equation, that Ft is equal to 900A plus 320 newtons, and we have to substitute that in for Ft in our equation that we just came up with. So we'll do negative 240 newtons minus, and now I'm going to go back to that nice green color. I'll plug in Ft. 900A plus 320 N. Go back to my blue. Equals our 1,200 A. I'm going to distribute the minus sign through, so I get negative 240 newtons minus 900 A minus 320 newtons equals 1,200 times acceleration. We're going to combine like terms. So we have negative 240 plus a negative 320 gives me a negative 560. Negative 560 newtons minus 900A equals 1,200A. I'm going to add 900A to both sides. So that equals 2,100A. And then let's write the whole thing out. We got negative 560 newtons equals 2,100 times acceleration. So now that we have it in this form, let's think about what this is. We've got newtons, right? Forces. This is the sum of the forces on the entire system. And it's equal to the mass of the system times its acceleration of the entire system. So we can see that the mass is here. There's our variable A. And then this must be the sum of the forces. So we go up. What's the mass of the system? Well, that's the total mass. That's the 900 plus the 1200. It's the 2100. Check. What's the magnitude, right? That's just the absolute value of the force. Magnitude is 560 newtons. Hooray, we got it. What's the magnitude of the system's acceleration? Uh-oh, we haven't solved that yet. But thankfully, we are in a situation where we have just one unknown. We know it's negative 560 is equal to the 2100A. I can just divide by 2100 to get A by itself. A is equal to 560 negative divided by 2100 equals, let's see, 560 divided by 2100. I get negative 0.267. So it's a negative 0.267 meters per second squared. And go up, and we see that's the value. Excellent. Describe the system's speed. Well, we see it's got a negative acceleration, which means that its velocity is changing opposite the direction of motion. Since we are told the direction of motion in this problem is to the right, then if we have a negative acceleration, that means our object is slowing down or decreasing speed. We have to look at the sign convention. Negative for us, in regards to our motion coordinate system, negative means that we're going, or that force is causing an acceleration opposite the direction of motion. And then it says how much tension is in the cable. So our final step now, let's pick a color we haven't used. How about this purple? Our final step is to take this acceleration and to plug it into an equation that has T in it. Well, if we go all the way back up, we see that the force of tension T is equal to 900 times A plus 320 newtons. So let's use it. Force of tension T equals 900 times A plus 320. So that equals 900 times a negative 0.267 coming from this number here, plus 320 newtons. Take our calculator. We've already got the acceleration stored in the calculator. Times 900 gives me negative 240 plus 320 gives me 8 times 10 to the negative 1, which is 80. I don't know why my calculator decided to go into scientific mode, but 80 newtons of force. And we see how much tension is in the cable. Sure enough, that's 80 newtons. Yikes. A lot of math, a lot of staying organized, a lot of substitution and rearrangement, just a lot of work. So when we walked through this problem, first step is obviously drawing a free body diagram for each part of your system you want to analyze, setting a motion coordinate system, calling the direction of motion positive, summing the forces for each free body diagram, setting them equal to MA, solving for acceleration, using the acceleration back in one of your original equations to solve for tension, looking at sign convention to determine if the object's slowing down or speeding up, or if it's not changing speed at all. I hope this helped. If you need extra help, please email me or stay after school. We do not have flex this month. I hope you have a good night.